Welcome back, Agent, to Spy School. This is Spy Training Lesson 3, Encoding, Plaincode to Ciphertext. We are at the last step of the encoding process, this plaincode using the one-time pad to get the encoded message or the ciphertext. Now remember, what we've done before is we did this step where we took this message, hello agent, and we used the checkerboard and the code book to come up with plaincode, and that's the plaincode. And then we just rewrote the plaincode in groups of 5 numbers. The reason why we wrote them in groups of 5 numbers is because the one-time pad is also written in groups of 5 numbers. That just makes it a lot easier. Let's go ahead and take a quick look. This is from the Number Spies Red Book, but you'll notice that there are different one-time pad pages here, different sets of numbers, but you'll notice that they all have this first grouping of 5 numbers as bold, and that's just to remind you that that number is not to be encoded because it needs to be part of the final message just as is, so that the spy that's receiving the message can use these first 5 digits to then go through and find their one-time pad so that they know which sets of numbers to use to decode it. So let's go ahead and take a look at what we're going to do here in this message. Before we get started, well, I guess let's take a look at this facing page. Every one of these one-time pad sheets has a facing page, which is a quick summary of what the encode-decode process is. So we've already, like we said before, we've already gone through the step of taking the message and converting it to plaincode, and then here are the same plaincode numbers that we had here. Now this isn't secure. This is just a simple changing of numbers and letters and numbers into digits, and that's not secure. The thing that makes it secure is the one-time pad. So, but before we get to this part, notice here that this is prefixed with 5 X's. Just do that to remember that when we do our step where we've got the one-time pad, that we don't want to do anything with these first 5 digits. We don't want to do anything to them. We want them to come down straight as it is. And notice these last 3 lines are kind of set up like a math problem. So these digits line up. You take the plaincode, which we have here, you take the one-time pad, and you're going to subtract the the one-time pad from the plaincode to come up with a digit. So think about all of these as individual math problems, number by number, like column by column. And that's how we come up with the ciphertext. That's what makes this message so hard to decode, because you have to have the exact one-time pad that matches with that. So in this case, we're going to go ahead and just copy this one-time pad here that we have in the sample, and we're going to place that under here. Now, if it's easier for you to do your math, column by column, you can do it like this as well. It doesn't really matter, because in the end, we're going to come up with a number that will group in 5s for our ciphertext. So what this is doing here is going to remind us that these first 5 digits aren't encoded. We're just going to copy those straight down. So that's going to be our first 5 digits of our ciphertext is going to be the same thing as the first 5 digits of the one-time pad. So then we do this math problem, and we do 7 minus 2 is 5. So it's just the top number minus the bottom number, and that's how we're going to come up with this thing. So 5 minus 5 is 0. 2 minus 4, that's going to come out with a negative number. We can't have a negative number. So what we're going to do is we're going to pretend like we're adding a 10 to this number. Let's do that like that. So now it's going to be 12. So 12 minus 4 is 8. So that's how we handle negative numbers. So we're going to keep going down here. 7 minus 7 is 0. 8 minus 7 is 1. I'm going to bring this up to, so it's either, so 7 minus 8, so that's going to be 17 minus 8. And that's going to be 9. And we can kind of recheck our math here. We can do 9 plus 8 is 17, and so that matches. So that's 7. 15 minus 9 is going to be 6. 9 minus 9 is 0. 9 minus 8 is 1. That's going to be 0 minus 0 is 0. 10 minus 8 is 2. 5 minus 3 is 2. 5 minus 1 is 4. 9 minus 1 is 8. 11 minus 3 is 8. 9 minus 6 is 3. 11 minus 2 is 9. 9 minus 1 is 8. And 1 minus 0 is 1. So let's go ahead and just take this and regroup them in groups of 5 again. And let's see if we did our math and came up with the same answer here. So this would be some unencoded number 09226, 09226, 50801, 50801, 97601, 97601, 02248, 02248, and 83981. All right, so that matches up with this. So just you can always check your math as you go along, but that is the step that we need to come up with the ciphertext. And remember that these first 5 digits are the same as the original first 5 digits of the one-time pad, and that is how the person receiving the message knows to look up and find that exact pad so that they know what numbers to write here. And this is just a simple subtraction problem for each of the digit columns as we go across, and that's how we get our ciphertext. Congratulations, agent.